Alright, up to now we talked about 4 different curves, or really 6 different curves. Now we're going to actually start going in and using some of these curves. Alright, the linear one is the one we're going to start with, and it's something you've already had some experience with. And I know your prior teachers should have been able to teach you at least some of it, but what we have to do is we have to understand on linear that the equation is y equals mx plus b. I know we've talked about it in class several times. Now we need to be able to understand what we're doing. Well, we know what x and y are. What we have to know is what does m and the b really do? Excuse me. Well, the m is exactly what we've talked about before. It's slope. And if you look on your algebra sheet, you'll see it. M is y2 minus y1 over x2 minus x1. Or is also the rise over the run, okay? And it's how we can move from one point to the next on a graph. A pretty simple explanation. Let's start with an equation, because it's easier to see that way. Y equals 3x plus 1. Now, understand here that we can actually start with a table, and if I make a table over here of x and y coordinates, and I pick 0 to start at. I always like picking 0. Right? 3 times 0 is 0, so all that I have left is y equals 1. Now, when x is 1, that gives me 3 times 1 is 3, plus 1 is 4, okay? And so y is 4. When x is negative 1, 3 times negative 1 is negative 3, plus 1 is negative 2. All right. Now, you only need 2 points to draw a line, but I always try to go 3 or 4 points, excuse me, on the table just to check it. All right. And I can see that if I start on the y-axis, because if x is 0, I'm on the y-axis, key point, right? Key point. If x is 0, this disappears, and all I'm left with is that. That is our starting point. Anytime we try to graph this, we simply look at what we have is b, and we put that on the y-axis. This only works on linear, okay? So remember, it is y equals mx plus b. When x is 0, y is whatever's added or subtracted out here. Now, if you don't have anything, then obviously y is 0 as well. All right, but in this case, we're at positive 1. So I'm going to graph that right there. All right. If you keep seeing that screen pop up or whatever where it shows me to rotate it and all that, don't worry about it. It's sensitive to how long I stay on the graph. All right, so I have that point, and I go look at my next point. It says 1, 4. So I go 1 to the right, up 4. 1, 2, 3, 4. And I now have another point. Okay. Now, if I look at the next point on my table, it is negative 1, negative 2. So if I go to the left 1, because that's negative, and down 2, I have a point right there. Now, all 3 of these points should lie on a line that basically is about like that. Now, that's freehand, so don't get upset about it being, oh, it's got to be perfect. No, no, no. No, we don't. No, we don't. We're good. We're just that good. Okay? So I have this, and I want to be able to use it to solve equations. Okay, well, I know what to do with the equation. What happens if I have 2 graphs or 2 lines, and I want to be able to solve it for where these lines meet? Well, remember the other day when we were talking about about the warm up, and I actually showed you we could break apart 2 equations or 2 sides of an equation that had this same variable and set them both equal to y. And let's say for this second one, I make y equal negative 5x plus 9. Now, I want you to think about what I talked about, a key little feature that sits out in front of x. And no, I'm not talking about the coefficient. I'm talking about the sign, okay? Notice on the y equals 3x plus 1, there's no sign, so it's actually positive. Well, that means we have positive slope. Well, look on this one. It says y equals negative 5x plus 9. So I know this thing is going to go from the top left downward to the lower right, somewhere in that area. But now what I have to look at is, again, if x is 0, my -5 doesn't mean anything to me. All I have to look at is my 9. So I'm going to go up 9 on my y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put a point. Now, remember, this is -5 over 1. Okay, just like the or just the positive 3 was over 1. -5 over 1 means I can go down 5, but to the right 1, because -5 is the negative side of it, which means I go down the y, and the 1, which is the x term, is positive, or the difference is positive, so I'm going to go to the right, which is a positive direction. So I'm going to go down 5, 1, 2, 3, 4, 5, and to the right 1. And look where I end up at, okay, on this same point. So if I draw a line that comes down through here, something, I can do better than that. That's close enough, okay? And that is the line for that equation. Now, so if I'm given two equations, I can create their lines, and I'm going to look for the point of intersection. This point is very important. That point is at 1. Let me draw it over here and put it over here. That point is 1, 4. Okay, let's get it over here. 1, 4. All right, so it's really important I use that point, okay, or understand that point, what it means. And if I was to make a table for the y equals -5x plus 9, it would also find, well, let's just do that. Let's see what that does for us. Let's do a table, because you have to be able to solve this with a table, with an equation, with a graph, and a verbal description, okay? And from the verbal description, you're just going to make your equations. So, all right, so if I have 0, I always start there. Remember, we're going to have 9. That should be a 0. If I have 1, that is -5x plus 9 gives me 4. -1. -1 times -5 is 5 plus 9 gives me a positive 14. Obviously, that's way off the graph, but it's close enough that we just needed to see the two equations. Well, here's what we need to note. That point right there and that point right there both come from this. Okay? So yeah, we do have an intersection point. So now we can see on the tables, that we have an intersection point. We can kind of see on the graph, but you never want, especially a hand-drawn graph, you never want to, excuse me, you never want to fully read it. Now, if it's drawn in for you, it's probably pretty close and pretty safe to look at least. But I always try to find the equation of a line first, and then go check to see what their intersection point is. All right. So what I need to do is, that means that either one of these equations, I can plug one back in for x, and both of them are going to give me 4 for a result, which is what we did to create the table. All right. So we're going to move forward with this and try another. All right. Let me erase everything and go. Let's see here. Clear drawings. All right. Remember, we're still going to keep the y equals mx plus b form. Plus b. All right. And let's go with some that's not so easy, okay? And what I mean by that is, we're not going to come out with a nice, easy, 1 and 4. Because you guys, as much as I tell you I hate fractions, I still know how to deal with them, okay? And I need you guys to be able to deal with them. So I'm just going to come off with 2 right off the top of my head, and I'm going to say y equals, let's try x minus 2. And y equals, let's make it simple enough, -3x plus 2. Okay? Well, first off, you're probably thinking, oh, okay, well, I can get rid of the 2's. Well, no. We have to think about this. So to solve this with a graph, I'm going to plot the first one. And remember, I go to my b. When x is 0, y is -2. Well, the only point x is 0 is along the y-axis, so I go to -2, and I plot it right there. And let's say, look at our m, which is right here, which is 1. I'm going to go up 1 and over 1, and right there. Okay? And if I draw that line, let's see here if I can draw this through the proper ones. Let's see here. I'm basically going to have a one that comes right down through here. Okay, close enough. All right. So now let's pick out the red for our second one. And I'm going to go here, and it says positive 2, 1, 2. All right. Now I'm looking at my slope, and what I need to see is that my slope says that's negative 3 over a positive 1. Okay. So from this point, I can actually, without even, if you notice, I haven't built a single table, really. Okay. So from this point, I'm going to go down 3, 1, 2, 3, and to the right one. Oh, I thought I was going to pick a hard one for you, just kind of randomly pick them. And looky here. This one comes out that I draw a line right down through these points. And I'll bet my answer for both of them is going to be, let's back up. It's going to be 1, negative 1. Let's plug that in. If x is 1 for the first one, that's 1 minus 2, that's negative 1. Let's try it on the second one. Negative 3 times a positive 1 is negative 3, plus 2, negative 1. So here, from just using my two equations, I've actually graphed it, and I could read where they intersect at, and that is exactly my point. What that means is that is the one point on this whole graph that will satisfy both equations, and that's what we need to be able to do. We need to be able to read an equation, or we need to be able to read a graph and solve what point these two lines have in common. Okay? And let's see. I'm going to put one more on here. Let's go ahead and erase everything. And I want to, let me see if I can come up with one. And I want you to try it. I wish I would have given you that one. Just to see what happens. Let me think about some equations. I'll be right back. Okay, so here are two equations I want you to use. I want you to use y equals 2x plus 5 and y equals x plus 6. Now, if you notice, neither one of these are negative in front of the x. Will they intersect? Let's find out. What I want you to do is I want you to pause the video, and then I want you to go do these on a piece of paper and draw a graph if you can, or if you have graph paper, that's even better because we know the paper is going to have an exact amount. But try these two equations and see what you come up with. Come back to the video and finish playing it at that point. Okay? So I'm going to wait about 2 seconds, and that should be enough time for you to pause. Okay, coming back to it, I want you to see, let's see if this worked. All right, so I'm going to plot my first one at 2x plus 5. So I'm going to go 1, 2, 3, 4, 5. And it says I'm going to go up to the right one. Now, I could have, if you understand, working with positives and negatives, 2 over 1, if they're both positive, right, it means I go upward for 2 and to the right for 1. But what happened? Couldn't I get the exact same thing by going down 2 and to the left 1? Let's find out. 1, 2, negative 1. All right? Just adding this in. I didn't expect you to have it. But once you have 2 points, you can form these lines. Now, you could have gone in there, hopefully, if you got stuck, you could have gone and made your table. All right? If you haven't made your table and you're still stuck, go ahead and pause it again and try it with a table. Okay, now that we're back, let's go ahead and try this with a line that's going to go down through all 3. Okay, so here's our point. Now, I still don't like that one. Let's see here, see if I can do better. I guess I need to get my other hand in here, see if I can draw it. That's a little better. Okay, so I'm going to use green this time for the other one. And let's start with our positive 6. So we know that one is at 5. I'm going to go up here at 6. And then my slope here, remember, my slope for this one is m equals 1 over 1, or 1. Means for every one up, I go 1 over, and looky there, I'm right at the same point. I draw my line through those 2 points. Okay, hey, that was actually halfway straight. All right, so that is my other point, or my other line. Now I can look at these two then and try to figure out where my point of intersection is, or it's actually easier if you see it on the graph. I'll bet my point is going to be at 1, 2, or let's see, it'd be 1, 1, 2, 3, 4, 5, 6, 7. Okay. All right, so I'll bet if we end up with the 0.17 as our intersection point, 2 times 1 is 2, plus 5 is 7, x is 1 on the second one, plus 6, yes, it is 7. So our point of intersection is 1, 7, and basically what that means is our x term is 1, y term is 7 for both equations, and they have that in common. That's the only point they will have in common. If that makes sense, let's go ahead and try one that won't come in. So let me erase one more time, and I know the video is starting to get a little long. All right, but I want you to practice this. This is going to be part of your homework, because I'm going to assign or bring up another file on there, and I want you to do what the problems are on that file. Okay, last one. I'm just going to wing it here. Y equals 3x plus 4. And on the other one, y equals negative 4x minus 1. All right. Now I haven't figured out whether these are going to work or not, so we're just going to put them on here. Well, let's go with the first one. And remember, we start with our b, right? And it's a positive 4. So we go 1, 2, 3, 4. And that's where we're going to put that one, start at. And we can go up 3, or if we needed to make the table, we could actually see our table. Let's see here, x, y, and 0 was 4. When 1, 3 times 1 is 3, plus 4 is 7. Negative 1 times 3 is negative 3, plus 4 is 1. So we can actually see that negative 3, 1, or I'm sorry, negative 1, 1 is a point. Try to get this in here. Negative 1, 1. And we also could have gone 1, 7. So 1, 2, 3, 4, 5, 6, 7. Okay, I draw that line, and it's going to go right down through those 3 points. Close enough. And then I'm going to draw the line for y equals negative 4x minus 1. Yes, notice this one does have a negative, so it's going to be an easy negative slope. If you remember on the last one, both lines were positive, and they still had an intersection point. All we're worried about is the intersection point, and it's a lot easier to see when you have a positive and a negative slope. You know for a fact that they're probably going to intersect at some point. So let's take a look. By now, some of you probably have already plotted it. It is negative 1 when x is 0. And then I'm going to go down 4, 1, 2, 3, 4, and to the right 1. And here's the other thing, just taking a quick deal. Let me put it over here in yellow. When I have the slope of negative 4 over 1, isn't that the same as 4 over negative 1? Basically, all I'm doing is moving my negative top bottom. It doesn't matter. I still have a negative 4 over 1. All right, so I'm going to go draw this in. And I could have gone using this second one. Okay. I could have gone up 4 and to the 1 left. 1, 2, let's see, 1, 2, 3, 4, and to the left 1. Puts me right in about there. Okay? I know that's a big point. There we go. All right, so let's draw that line. And that line is going to go right down through here, or pretty close to it. Now you can see our point of intersection is really far off. So this is an example of why you would not want to try to always read from a graph, a point of intersection, but it will give you a quick idea. So let's take a look where this one might be. The only way you can solve this, the best way to solve this, is you're going to find, without a calculator, you're going to set these equal to each other. So I'm going to set these, let's see here, 3x plus 4 on one side, equals, and it's going to be negative 4x minus 1 on the other side. Okay, so now I'm going to rework this whole thing, and I'm just going to use black ink for it. So I'm going to add 4x, and that cancels these out, and I get 7x plus 4 equals negative 1. So now I subtract 4 from this side, subtract 4 from this side, and I get 7x equals negative 5. Now I have to divide by 7, and I get x equals negative 5/7. Now, tell me you could plot that one. We know it's less than 1, right? We know that that point right here is less than negative 1, which is going to be on this line. Okay, so we know that. So what I have to do is I have to take that, and I'm going to plug it back into one of my equations. And I always like to try to play with it so that it's going to make it somewhat easier to work with. So I'm going to use the second one. All right, let's see here. I'm going to erase some of this information now. Let's see here if I can erase all of this so I've got a little bit of room to work. I'm going to keep our solution. Okay, and we know that our ordered pair is going to be, let's see here, it's going to start out that our ordered pair is, the x term is negative 5/7. Let's find out what our y term is going to be. To do that, I'm going to take this and put it back into the equation. I like to use the bottom one just because that one's negative and my answer for x is negative, going to give me a positive. So I'm going to go y equals negative 4, and make sure you get that negative in there, times a negative 5/7. And I'm going to subtract 1 from that. So negative 4 times negative 5/7 is positive 27 minus 1. And 27 is 2 6/7 minus 1. So my answer for y equals 1 6/7. So if I want to change that back to an improper fraction, I can go 1 times 7 is 7 plus 6. That gives me my y is 13/7. It would have been very hard to find that using a table. You really couldn't see that on the graph, but by using one of those points, or just the x term that you found from solving the two equations, you were able to come up with your y term, and then therefore you can find the actual intersection point. This is your intersection point and the point that satisfies both of these equations. I'm going to give you homework. Try this. Go back to this video if you have problems. I know it's 23 minutes long. Just try it and see what you can do. If you have to, go back to doing a table for each one. It will at least get you started. That'll plot it, and then plug your x, whatever you solve for x, plug it back into one of them, and you'll get your y.